இந்த வீடியோவில் நம்ம பார்க்க போகிறது கெமிஸ்ட்ரி ரெடியூஸ்டு சிலபஸ் 2021 to 2022 for 11th standard. ஸோ ஃபஸ்ட்டு சாப்டர் எடுத்துக்கோங்க. பேசிக் கான்செப்ட்ஸ் ஆஃப் கெமிஸ்ட்ரி அண்ட் கெமிக்கல் கால்குலேஷன். 1.4 மோல் கான்செப்ட், 1.4.1 அவகாட்ரோஸ் நம்பர், 1.4.2 மோலார் மாஸ், 1.4.3 molar volume, 1.5 gram equivalent concept, 1.5.1 equivalent mass of acids, bases, salts, oxidizing agents and reducing agents, 1.6 empirical formula and molecular formula, 1.6.1 determination of empirical formula from elemental analysis data, 1.6.2 calculation of molecular formula from empirical formula, 1.7 stoichiometry, 1.7.1 stoichiometric calculations based on stoichiometry, 1.7.2 limiting reagent, 1.8 redox reactions, 1.8.1 oxidation number, rules to calculate oxidation number, calculation of oxidation number using the above rules, redox reaction, terms of oxidation number. Chapter 2 Quantum Mechanical Model of Atom. 2.1 Introduction to Atom Model. 2.1.1 Bohr Atomic Model, that is Atom Model. 2.1.2 Limitation of Bohr's Atomic Model. 2.2 Wave Particle Duality of Matter. 2.2.1 Quantization of Angular Momentum and de Broglie's concept. 2.2.2 Davison and Germier experiment. 2.3 Heisenberg uncertainty principle. 2.5 Quantum number principle, quantum number n, azimuthal quantum number I or subsidiary quantum number, magnetic quantum number m, spin quantum number s. 2.5.2 energies of orbitals. 2.6 filling of orbitals. 2.6.1 Afuba principle. 2.6.2 Paul's exclusion principle. 2.6.3 Hund's rule of maximum multiplicity. 2.6.4 electronic configuration of atoms. 2.6.5 stability of half filled and completely filled orbitals. Symmetrically distribution of electron exchange energy. Chapter 3 Periodic classification of elements. 3.2.1 Modern periodic table. 3.3 Nomenclature of elements with atomic number greater than 100. 3.4 Grouping of elements based on electronic configuration. 3.4.1 Variation of electronic configuration along the periods. 3.4.2 Variation of electronic configuration in the groups. 3.5 Periodic trends in properties. 3.5.1 Atomic radius. 3.5.2 Ionic radius. 3.5.3 Ionization energy. 3.5.4 Electron affinity. 3.5.5 Electron negativity. 3.6 Periodic trends in chemical properties. 3.6.1 Anomalous properties of second period elements. Diagonal relationship. 3.6.2 Periodic trends and chemical reactivity. Chapter 4 Hydrogen. 4.1 Introduction. 4.1.1 Position in periodic table. 4.1.2 Isotopes of hydrogen. 4.1.3 Ortho and para hydrogen. 4.2.3 Preparation of deuterium. 4.2.4 Preparation of tritium. 4.3.3 Chemical properties of deuterium. 4.3.4 Properties of tritium. 4.5 Components of hydrogen. 4.5.1 Water. 4.5.4 Hard and soft water, temporary hardness and its removal, permanent hardness. 4.6 Heavy water. 4.6.1 Chemical properties of heavy water. 4.6.2 Uses of heavy water. 4.8 Hydrides, ionic saline hydrides, covalent molecular hydrides, metallic interstitial hydrides. Next, fifth chapter, alkaline and alkaline earth metals. 5.1 S block elements, 5.2 alkali metals, 5.2.1 general characteristics of alkali metals, 5.2.2 distinctive behavior of lithium, 5.2.3 chemical properties of alkali metals, 5.2.4 uses of alkali metals, 5.3 general characteristics of the compounds of alkali metals, 5.5 alkaline earth metals, 5.5.1 general characteristics of alkaline and earth metals, 5.5.2 distinctive behavior of beryllium, 5.5.3 chemical properties of alkaline earth metals, 5.5.4 uses of alkaline earth metals such as magnesium, calcium, 5.6 general characteristics of the compounds of the alkaline earth metal, 5.6.4 plaster of Paris. Sixth chapter, gaseous state. 6.1 introduction, 6.2 the gas law, 6.2.1 Boyle's law, pressure volume relationship, 6.2.2 Charles law, volume temperature relationship, 6.2.3 Gay-Luss's law, pressure temperature relationship, 6.2.4 Avogadro's hypothesis, 6.3 ideal gas equation, 6.4 mixture of gases, Dalton's law of partial pressure, 6.4.1 Graham's law of diffusion. Next, seventh chapter, thermodynamics. 7.1 introduction, 7.2 system and surroundings, 7.2.1 types of system, 7.2.2 properties of system, 7.2.3 thermodynamic process, 7.3 zeroth law of thermodynamics, 7.4 first law of thermodynamics, 7.4.1 mathematical statements of first law, 7.5 enthalpy, 7.5.1 relation between enthalpy H and internal energy U, 7.5.2 enthalpy changes for different types of reaction and phase transition, 7.6 thermochemical equation up to heat of combustion, 7.8 Hess law of constant heat summation, 7.9 lattice energy, 7.10 second law of thermodynamics, 7.10.1 spontaneity and randomness, 7.10.1 standard entropy change, 7.10.1 standard entropy of formation, 7.10.1 entropy change accompanying the change of phase. Chapter 8, physical and chemical equilibrium, 8.3 chemical equilibrium, 8.4 dynamic nature of equilibrium, 8.5 homogeneous and heterogeneous equilibria, 8.5.1 homogeneous equilibrium, 8.5.2 heterogeneous equilibrium. 8.6 laws of mass action, 8.6.1 equilibrium constant Kp and Kc, 8.6.2 relation between Kp and Kc, 8.6.3 equilibrium constant for heterogeneous equilibrium, 8.7 application of equilibrium constant, 8.7.1 predicting the extent of a reaction, 8.7.2 predicting the direction of a reaction, 8.7.3 calculation of a concentration of a reactants and products at equilibrium, 8.8 Leo-Chatelier's principle, 8.8.1 effect of concentration, 8.8.2 effect of pressure, 8.8.3 effect of temperature, 8.8.4 effect of catalyst, 8.8.5 effect of inert gas. Next, ninth chapter, solutions, 9.1 introduction, 9.2 types of solution, 9.3 expressing concentration of solution, 9.3.1 standard solution and working standard, 9.3.2 advantage of using standard solution, 9.4 solubility of the solute, 9.4.1 factors influencing the solubility, 9.5 Hernes law, 9.5.1 limitation of Hernes law, 9.6 vapor pressure of liquid, 9.7 vapor pressure of liquid solution, 9.7.1 vapor pressure of binary solution of liquid in liquid, 9.7.2 vapor pressure of binary solution of solid in liquids, 9.8 ideal and non-ideal solution, 9.8.1 ideal solution, 9.8.2 non-ideal solution. 9.9 colligative properties, relative lowering of vapor pressure, elevation of boiling point, depression in freezing point, osmosis and osmotic pressure. Next, chapter 10. Chemical bonding. 10.1 Introduction. 10.1.1 Kossel-Lewis approach to chemical bonding and octet rule. 10.2 Types of chemical bonds. 10.2.1 Covalent bond. 10.2.2 Representing a covalent bond by Lewis dot structure. 10.2.3 Formal charge. 10.2.4 Lewis structure for exception to octet rule. 10.3 Ionic or electrovalent bond. 10.5 Bond parameters. 10.5.1 Bond length. 10.5.2 Bond order. 10.5.3 Bond angle. 10.5.4 Bond enthalpy. 10.5.5 Resonance. 10.5.6 Polarity of bonds. 10.6 VSEPR theory. 10.7 Valence bond theory. 10.7.1 Salient features of VB theory. 10.8 Orbital overlap. 10.8.1 Sigma and pi the bonds. 10.8.2 Formation of H2, F2, HF, O2 molecules. 10.9 Hybridization. 10.9.1 Types of hybridization and geometry of a molecule. 10.10 Molecular orbital theory. 10.1 that is 10.10.1 Linear combination of atomic orbitals. 10.10.2 Bonding in some homonuclear diametic molecules. 10.10.3 Bonding in some heteromolecular diametic molecules. Chapter 11 Fundamentals of Organic Chemistry. 11.1 Introduction, Characteristics of Organic Compounds. 11.2 Classification of Organic Compounds. 11.2.1 Classification based on structure. 11.2.2 Classification based on functional group. 11.3 Nomenclature of Organic Compounds. 11.3.1 IUPAC Rules for Nomenclature of Organic Compounds except Table. 11.6 Rules for Naming of alicylic compounds. 11.5 Isomerism in organic compounds. 11.5.1 Constitutional Isomerism. 11.5.2 Stereo Isomerism. 11.5.3 Geometrical Isomerism. 11.5.4 Optical Isomerism. 12 Basic concept of organic reactions. 12.1 Introduction. 12.1.1 Fundamental concept of organic mechanism. Organic reaction mechanism. 12.1.2 Fission of a covalent bond. 12.1.3 Nucleophiles and electrophiles. 12.1.5 Electron displacement effects in covalent bonds. Next, 13th chapter Hydrocarbons. Introduction. 13.1 Introduction and classification of alkenes. 13.2.1 Preparation of alkenes. 13.2.2 Physical properties. 13.2.4 Chemical properties uses. 13.3.1 General method of preparation of alkenes. 13.3.2 Physical properties of alkenes. 13.3.3 Chemical properties of alkenes. No mechanism except recycling plastics. 3.4 uses of alkenes. 13.3.4 uses of alkenes. 13.5 Aromatic hydrocarbons. 13.5.2 aromaticity. 13.5.3 Structure of benzene. 13.5.4 Sources and preparation of benzene. 13.5.5 Physical properties. 13.5.6 Chemical properties of benzene compounds. 13.5.7 Directive influence of functional group and monosubstitute benzene. 14th chapter Haloalkenes and halorins. 14.1 Introduction. 14.2 Classification of organic halogen compounds. 14.3 Haloalkenes. 14.3.1 Nomenclature. 14.3.2 Nature of a C bond X bond, that is C C-X bond in haloalkene. 14.3.3 haloalkenes preparation. 14.3.4 physical properties. 14.3.5 chemical properties of haloalkenes. 14.3.6 uses of haloalkene. 14.4 organic metallic compounds. 14.4.1 preparation. 14.4.2 uses of Grignard reagent. 14.5 haloarenes. 14.5.1 nomenclature of haloarenes. 14.5.2 nature of C-X bond of in haloarenes. 14.5.3 methods of preparation. 14.5.4 physical properties. 14.5.5 chemical properties. 14.5.6 uses of chlorobenzene. Practicals. Salt analysis மட்டும்தான் உங்களுக்கு இருக்கு கெமிஸ்ட்ரியில +1ல. So first one lead nitrate, second one copper sulfate, third one ferric chloride, fourth one zinc sulfide, fifth one aluminium nitrate, sixth one calcium carbonate, seventh one ammonium bromide, eighth one magnesium phosphate. ஸோ இந்த வீடியோ உங்களுக்கு யூஸ்ஃபுல்லாக இருக்கும்னு நினைக்கிறேன். ஸோ இந்த வீடியோ உங்களுக்கு பிடிச்சிருந்தா ஒரு லைக், ஷேர், சப்ஸ்கிரைப் டு சயின்ஸ் ஈஸி டெக் சேனல். என்னோட பழைய பயாலஜி வீடியோஸை நான் டிஸ்கிரிப்ஷன் பாக்ஸில் கொடுத்துருக்கேன். உங்களுக்கு ஏதாச்சும் டவுட்ஸ் இருந்தால் கமெண்ட் பாக்ஸில் போடுங்க.